guys, so we've talked a lot about derivatives of logs and exponentials. We've talked about the derivative of the natural log of x. We've talked about the derivative of e to the x. We've talked about the derivative of any exponential function with any base. And then you're thinking, man, life is good, except we're missing something. And no, I'm not talking about Portillo's chopped salad. I'm talking about log derivatives of other bases. So for example, like if I had y equaled log base 7, because that was my volleyball number in college, remember that. If I said, what's the derivative of log base 7 of x? That looks like a z. I'm sorry. And then you're like, I don't know, because you never taught us. Well, no more. What's the derivative of log base a of x? All right. Well, first of all, let's change this to y equals log base a of x. And you're like, oh, let's take the natural log of both sides. And I'm like, whoa, way to pay attention. But no. Let's rewrite this as natural log of x over natural log of a first. How did I do that? 3 words? You're right. Change of base. Excellent. Okay, so let's take the derivative of this as is. Now I want you to remember that natural log of a in this denominator here is just a number. So we don't need to use our quotient rule. So when I take its derivative now, well, it would just be 1 over natural log of a times whatever the derivative of natural log of x is, which is 1 over x, which makes it 1 over x natural log of a. Sweet! So now you know. Now life is all good. And if you want to get me that Portillo's chopped salad, I will not be upset. That's the best thing ever. Anyway, so the derivative of log base a of x is 1 over x times the natural log of a. Now notice that the natural log of a is in the denominator. If you were to write it as if it were in the numerator, that would be wrong. Wonderful. Same thing as we've done before is, let's say that I had log base a of something other than x, so like 14x to the 7th, right? Then don't forget that we do multiply by the derivative of that, and that is part of the numerator, just so you know, not the denominator. So, an example here, we want to find the derivative of f of x. If you want to try this on your own, go for it. If not, here we go. All right, well, the derivative, f prime of x, is, well, we know it's going to be 1 over this quantity times the natural log of the base. I'm making sure that that's in the denominator. And also times, chain rule, the derivative of what's inside, which is 4x cubed plus 0, so 4x cubed. The last thing I could do if I just want to make this look a little nicer. Why not if we can? Final answer. Awesome. So the derivatives of logs of other bases are derived using the change of base formula. You can always derive it on your own if you blank out on a test, let's say.